welcome to QLab. In this video we're going to practice titration calculations. I'm also going to provide a worksheet if you want to do some extra practice as well. Right, let's get started. A 50 milliliter solution of hydrochloric acid was fully neutralized by 20 milliliters of a 0.5 molar or moles per decimeter cubed solution of sodium hydroxide. Calculate the concentration of the hydrochloric acid solution. Now often we are given a chemical equation. However, for simple reactions like hydrochloric acid and sodium hydroxide, we should be able to write our own. So if one isn't given, the first thing we do is write a balanced chemical equation. This example is nice and simple, and we'll look at some more complex examples later when we do some practice. We then draw a vertical line between the acid and the base and place labels for concentration, volume, moles and ratio along the side. And then all we do is add the values we know from the question. So we can see that we know the concentration of the base, the sodium hydroxide solution, that's 0.5. I know it said molar, but it's moles per decimeter cubed. Just get used to this unit transition or transfer. And we've got the volumes of both solutions, so we know 50 milliliters of the acid and 20 milliliters of the base. Again, it's very handy if you can get used to converting between them. So 50 milliliters is 0.05 litres. And just remember the fancy term for litre is decimeter cubed, or dm cubed. So that's an easy transformation. And then we also know from the equation we've written that one molecule of HCl reacts with one molecule of sodium hydroxide. So we know the ratio is 1 to 1. So this little setup helps you keep track of all the information, and it's also useful to see how units can tell you about an equation. You see, we know now that concentration is equal to moles decimeters to the -3. So the concentration is equal to a mole value divided by a volume value. So the equation has come out of the unit, so we can find the equation using the units. And this is a very helpful trick when sometimes you can't remember an equation in an exam, but you're given some units to work with. Now we only have one space in the base column, so we can work this value out. We need to calculate moles, so rearranging the equation for concentration that we just got from the units by multiplying both sides by volume, we get concentration times volume is equal to moles. Again, it's very important that the units of volume are litres or decimeters cubed, same thing, and the concentration is in moles per decimeter cubed. Otherwise, the volumes, that decimeter and per decimeter cube, won't cancel out to give you moles. So using this equation, we can see that 0.5 moles per decimeter cubed times 0.2 decimeters cubed will give us 0.01 moles. Now we know from the ratio, those bottom numbers, that one mole or one molecule of sodium hydroxide reacts with one molecule of hydrochloric acid. So the number of moles of sodium hydroxide we used equals the number of moles of hydrochloric acid that we used, that were there. So we know that there was 0.01 moles of hydrochloric acid in that 50 milliliters of solution. And now you can see that we've only got one thing left to calculate, the concentration of the HCl. And we can do that with that equation, the first equation we picked out, because we have the moles and we have the volume. And so we take 0.01 moles divided by 0.05 decimeters cubed to give us 0.2 moles per decimeter cubed. And then what we want to do is write it explicitly so that any examiner and whatnot can see that we've very clearly stated that the concentration of the hydrochloric acid is 0.2 moles per decimeter cubed. Now there's a couple of things I want to just point out here, which is once you've finished this question, just do a little logic check. Remember that you had 50 millilitres of hydrochloric acid and it was neutralised by 20 millilitres of sodium hydroxide. So you've used a lot less volume of sodium hydroxide. So you know the concentration of your acid has to be lower than the concentration of your base. And if it's a 1-to-1, I should say if it's a 1-to-1 ratio. So now we're looking at 0.2 and we're like, good, that's lower than the 0.5 moles per decimeter cubed. I've gone in the right direction. That's just a helpful way of checking, just with a little bit of logic, whether you are going the right way. Because often with titration calculations, your errors are very large. If you make a mistake, the number will be way off. It won't be pretty close. Now, the other point here is that this can be adapted to ask you lots about different parts of this equation. For example, I could be really mean and say the volume of HCl, and I could tell you how many grams of sodium chloride, the salt, came out. Now you could work out from that how many moles of sodium chloride you had, and you'd look at the equation and go, but it's a ratio of 1-to-1. So then you know the moles of your HCl. So this method doesn't just have to be applied when you're using an acid and a base. If some nasty question asked you about, say, the salt volume as well, you can just shift over, look at the ratio between those numbers, and carry it forward to work out your concentration. So, time to practice. So let's work through a practice question. So what we can see here is an unknown solution of citric acid. We don't have to worry about what that is. 20 millilitres of it was titrated with a 0.8 mole per decimeter cubed solution of sodium hydroxide. A total of 32 millilitres of base was required to completely neutralise the acidic solution. Calculate the concentration of the acidic solution. So there's a couple of things we should know straight away. The acidic solution is obviously the citric acid, and the basic solution is the sodium hydroxide. Now in this case, and often is the case in an exam, if you don't know what the acid or base is, it's very likely you'll be given the equation, because that's not really what they're trying to test. They're not trying to test your memory of this equation. They want to test whether you know how to do this calculation. So let's set this one up by first drawing our line that runs between these two. I haven't done that very neatly, I'm afraid. I'm doing this sort of side on, so it's easier for the camera to pick up. And then what we want to do is we're going to put a little conch here for concentration. Hope that can pick that up. We'll put moles there. Oh, wait, I've done that wrong already. Volume there, and moles there, and ratio at the bottom. And then all we do is fill out what we know. Well, we know that 20 millilitres of the citric acid was used, and we can convert that straight into litres. Remember, 1 millilitre is 1,000th of a litre, so 20 millilitres are going to be 0.02 litres, or decimeters cubed. Because 0.1 would be 100, and 1 would be 1,000, so you can just work it back. And the volume of the sodium hydroxide was 32. Well, we can put that in 0.032 decimeters cubed. And we know the ratio because it's given to us in the equation. 1 molecule of citric acid reacts with 3 molecules of base. So 1 to 3. And we know the concentration of our sodium hydroxide solution. 0.8 moles per decimeter cubed. So we've put in all the information we know. And we can see pretty quickly that we can work out the whole of this column. So we can work out the number of moles here. Now sometimes it can be useful to write down the equations you might need. And remember, we can see from this that concentration, conc, is equal to moles divided by volume. And so we can work out from this, if we times both sides by volume, that conc times volume equals moles. So to calculate our moles here, we just have to do 0.8 moles per decimeter cubed times 0.032 decimeters cubed. And these two will cancel. Oh, that's supposed to be a per. Meant to be a minus sign there. These two will cancel and we'll just end up with moles. And that's fantastic, isn't it? So we're going to end up with 0.0, let me see if I can remember this right, 26 moles. And just check with your calculator that that's right, 0.026 moles. But we know, and this is very important here, when you have a different ratio, to sound it out. Because otherwise, or at least in your head, you often get these the wrong way around. We know that 3 molecules of sodium hydroxide react with every 1 molecule of our acid. So we know that this number is 3 times too big for our number of acid molecules, because 3 of them react with 1. So we need to divide this by 3 to get our number of moles of citric acid. And so that will be 0.0086, I believe. So we'll just underline the ones that we're actually calculating. There we go. And now you've got the number of moles and you've got the volume. So from our concentration equals moles divided by volume, all we have to do is divide this number by this number, as long as you've turned it into decimeters cubed, or litre, that is. And we'll end up with 0.4 moles per decimeter cubed. Now there's a little point here to remember, that actually you'll have a whole load of decimals off the end of this. But our significant figures are only to one significant figure. So we don't want to report our concentration as more than that. And so there we have it. That's our concentration. And we can write it explicitly just at the bottom, which will say something along the lines of the concentration of the citric acid solution is 0.4 moles per decimeter cubed. Full stop. Very clear, very explicit. Nobody can think you've mucked up here. Now if you wanted to show your working for each of these calculations, you could actually just leave yourself more space, maybe 2 or 3 lines for each of these. And then when you have to do a calculation, you can say, effectively you can write the formula, then you fill the formula in, and you put your answer. And in fact, we'll do that on the next question, just to show you how to lay that out. So once again, we've got a slightly unfamiliar compound here, which is pyridine. But we don't need to worry about that because we're given the formula. So a 0.1 mole per decimeter solution of hydrochloric acid was titrated against 100 millilitres of a pyridine solution. A total of 48 millilitres of acidic solution was required to neutralise the pyridine solution. Calculate the concentration of the pyridine solution. And here we're given the equation, and all we really need to know from here is that one molecule of HCl reacts with one molecule of pyridine. So let's set this up. Now sometimes if you don't have enough room at the side or something like that, you can actually just set it up a bit nicer, making better use of the page. I'm going to turn this slightly on an angle so that I can write a bit better. And so what you can do is you can do something like this. Acid, base, draw your line down the middle, and you can then put, let's say, concentration or conc. We'll leave some space. Volume, moles, and ratio. We don't need much room for ratio because we can pull that straight out of the equation. Now let's write what we know. Well, we know our acid solution is 0.1 moles per decimeter cubed. We don't know our base solution, but we do know the volume of the acid that was required. It was 48 milliliters, or 0.048 decimeters cubed. That's a very handy thing to remember, to know how to change between those numbers, and once you've practiced it a bit, it'll be very easy. And we know our base was 100 milliliters, or 0.1 decimeter cubed. And our ratio is 1 to 1. Now, we can't fill in things here yet, so this is a bit different. We're now looking at the acid this time round, but we know we can have a look at this, and we've only got our moles empty. Now when you do it in this way, there isn't too much space to write down your equations, but you can do it where you're using them. So we can say that moles are equal to conc times volume. And then we can fill in these numbers because we got them. 0.1, and you should write the units, but I haven't left myself quite enough space. 0.048, so we can put equals next. Then we can take it all the way down, and I can't remember off the top of my head what that is. Oh, yes I can, it's a nice and simple one. We're adding a 0. 0.0048 moles. And here's the interesting bit. When we do that little sort of sentence in our head, one molecule of HCl reacts with one molecule of pyridine, we know that the same number of molecules are involved. So we know instantly that the number of moles here is going to be equal. So it's going to be 0.0048 moles. Oh, let's just underline these because we've done our hard work. And then we go back up to here because now we've got all the numbers we need, and we can remember that concentration, remember it's in the equation here, concentration is equal to moles divided by volume. So it's equal to 0.0048 divided by 0.1. And so we know when you divide by 0.1, it's the same as timesing it by 10. Moles decimeter to minus 3. But if we look closely at this, it's actually too many significant figures. We've only got our concentration here to one significant figure, so I'm much more confident saying that this is actually going to be equal to 0.05 moles decimeter to the minus 3, and then you can put to one significant figure. Let's just underline that. And so again, explicitly you can write at the bottom that the concentration of the pyridine solution is 0.05 moles decimeter to the minus 3. Now there's just a quick thing to think about with this question, because there's actually a lot that's quite intuitive. You reacted, or we found that 100 millilitres of pyridine required almost 50 millilitres, so almost half the volume, to neutralise in a 1-to-1 ratio. So we knew pretty much straight away that our concentration of pyridine was going to be about half the concentration of our hydrochloric acid. And so when we look at this answer, 0.05, well, that's half of 0.1 to one significant figure. If you don't get significant figures and the like at the minute, I might put a video out on them so that we can understand how errors and things impact how accurately we give our answers. Well, thank you so much for watching. I hope that video was useful. We're going to carry on in the acids and bases series to look at the pH scale next, I think. Don't forget that I attached a worksheet if you want some extra practice. And if you like this video, why not give it a thumbs up and subscribe? It helps me make more of these videos. Anyway, thank you again, and bye!